Hey, welcome to The Explainer. Today we are diving into a really massive question. How do we actually see the world around us? You might think your eyes are just like little cameras, passively recording everything. But the truth? It's so much weirder and way more interesting than that. Let's just jump right in. All right, let's try a quick experiment together. I want you to look right at the character in the middle of this sequence. What is it? Just say it out loud. So, what you get? Did you see the number 13? Or did you see the letter B? See, if you read across, your brain almost certainly saw 12, 13, 14. But if you read down, you probably saw A, B, C. It is the exact same shape, but your brain interpreted it completely differently depending on the context. And that right there proves that seeing isn't just seeing. It's an active process of interpretation. And that leads us to this really profound idea. Your entire experience of reality is a construction. It's a story that your brain is constantly telling itself, using bits of sensory data and a whole lifetime of experience. So the big question is, how in the world does it build that story? Well, let's break it down. Okay, first things first, we have to understand that your brain uses all these hidden filters. Some are internal, some are external, and they're constantly deciding what information matters and how to make sense of it. And the crazy part, this is all happening completely under the surface, without you even noticing. Let's start with what's going on inside our own heads. First, you have what are called schemas. You can think of these like mental blueprints that help you organize all the information you encounter. You have a schema for dog, right? It includes things like fur, 4 legs, probably barking. Then you've got perceptual sets. This is more like a mental predisposition. It's being ready to see one thing instead of another. So in that first experiment, if you were thinking about numbers, your perceptual set just nudged you to see a 13. And you know, it's not just what's inside our heads. The outside world plays a huge role in shaping what we see. The context, like whether you were reading across or down, changes everything. Our expectations totally prime us to see what we think we're going to see. And of course, our personal experiences color our world in a huge way. Someone who's been in a bad car accident is going to perceive the risk of driving way differently than someone who hasn't. Okay, so our brain has all these filters, but how does it take all that raw, chaotic, noisy data from our eyes and somehow turn it into clear objects and scenes? Well, it uses this absolutely brilliant set of mental shortcuts, which were first figured out by a group called the Gestalt psychologists. They saw that our brains are hardwired to organize pieces of information into meaningful wholes. The most basic principle here is called figure ground. Take a look. What do you see? 2 faces looking at each other? Or a vase. Now, try to see both at the exact same time. You can't, right? Your brain has to make a choice. What is the figure, the thing you're focusing on, and what is the ground, the background? Your perception literally flips back and forth between the two. Next up is the principle of closure. Now, you're not seeing just a collection of random black shapes here, are you? No way. Your brain automatically fills in all the missing lines and tells you, hey, that's a soccer ball. It seems we have this deep, powerful need to see things as complete objects, even when the information isn't all there. Here's another one that's so simple but so powerful: proximity. Your brain doesn't see 30 separate little dots here. It sees 3 distinct columns. And why? Because we automatically group things that are close to each other. It's a really simple rule for creating order out of what could be just randomness. And finally, for this section, there's similarity. In this grid of shapes, you instantly see an arrow, right? Your brain isn't sitting there calculating each shape one by one. It's just grouping all the similar things, in this case the black circles, and sees them as a single related object that stands out from all the squares. It's just another amazing shortcut for finding patterns in the noise. So we know our brain filters information, and we know it organizes it into patterns. But here's the catch. We can only consciously process a teeny tiny fraction of all the information that's actually out there. What you truly perceive is determined by where you decide to point the spotlight of your attention. And attention is a two-sided coin. On one hand, you've got selective attention. This is your incredible ability to tune in to just one conversation at a loud party. You've probably heard of it as the cocktail party effect. But the flip side of that is inattention. When we focus really hard on one thing, we can completely fail to see other objects that are right in front of our faces. It's something called change blindness. So yeah, your focus is powerful, but it also creates some serious blind spots. And now we've arrived at what is maybe the most amazing feat of perception of all: seeing in 3 dimensions. Think about it. The image that's actually projected onto your retina is
totally flat. It's 2D. So how on earth does your brain create the rich, deep 3D world that you experience every single moment of every single day? Well, it uses a set of incredible tricks.
First off, your brain uses the power of having two eyes. Because your eyes are a little ways apart, they each see a slightly different image of the world. Your brain then takes those two different views and masterfully merges them. By calculating the difference between them, the disparity, it can basically triangulate distance and create this amazing sense of depth. But what's really amazing is that your brain can also perceive depth with just one eye. It does this using what are called monocular cues. And get this, these are the exact same tricks that artists have been using for centuries to create the illusion of depth on a flat canvas. Let's take a quick look at how they work.
Okay, first up is relative clarity. Just look at this fence. It's sharp, it's detailed, you can see every single curve in the wire. The background, though, it's all blurry and indistinct. Your brain uses a really simple rule here. Clearer things are closer. Next, we've got relative size. Your brain just knows that these two spray cans are identical in size. So when one of them appears much smaller on your retina, your brain doesn't think, oh, that must be a tiny little can. No, it instantly calculates that the smaller looking one has to be farther away. Simple.
And here we can see the texture gradient in action. Up close, you can make out individual cranberries, each one with its own shape and shading. But as you look farther and farther into the distance, all that detail just fades away into a smooth, uniform texture. That change is a really powerful signal for depth.
Oh, this is one we all know intuitively. Linear perspective. We know for a fact that these train tracks are parallel, that they don't actually meet up. But as they go off into the distance, they appear to converge at a single point. And that visual trick creates an incredibly strong and immediate illusion of depth. In our final cue is interposition, which you could also just call overlap. In this painting, you can see the trees are blocking parts of the horse. Your brain uses a super simple rule here. If one object is blocking another one, it must be closer. This lets us instantly see layers and distance in a scene.
So when you put it all together, from filtering information and grouping shapes to literally creating a three-dimensional world from flat images, your perception is this active, complex, and deeply personal construction. It's not a window, it's a story. Which leaves us with one last fascinating question to chew on. If your brain is the one building your reality, then who's the architect?